Hello everyone, my name is Sonbol. I'm going to present our paper with title of Sphere, Fast Multipass Payment with Redundancy. Consider Bob wants to make a payment to Carol in the Lightning Network. As you can see in the figure, Bob doesn't have a payment channel with Carol to make this payment. However, Bob has a payment channel with Alice and Alice has a payment channel with Carol. So Bob can use the Lightning Network and send payment to Carol through Alice. In the previous example, consider Bob doesn't have enough money in this channel to make Carol's payment. As you can see in the figure, Bob has a payment channel with David, who has a payment channel with Carol. So that means there is another path to send money to Carol. Unfortunately, Bob also doesn't have enough money in this channel to make Carol's payment. In this situation, Bob can use a multipass payment and split the payment into two partial payments. Then he can send these two partial payments through these two passes. In multipass payment, if a partial payment fails or is delayed, the whole multipass payment fails or is delayed. To address this, we propose a fast multipass payment method with redundancy is called Sphere. The added redundant payment is basically reduced probability of failure. However, adding redundant payments is challenging. It is because Carol may overdraw funds from redundant payment passes. There is only one method in the literature that uses redundant payments. It's called boomerang. Boomerang is a mechanism based on secret sharing and homomorphic one-way function. In the following, we show that Sphere is a simple method and has several advantages over boomerang. Consider Alice wants to send a payment to Bob in the Lightning Network. To do this, Bob first generates a random number and computes its hash image. Then he gives this hash image to Alice. In response, Alice selects a single pass to send a payment to Bob. For making a payment, Alice creates a contract with the next node in the path. Also, all intermediate nodes create contract together. The hash images in all of these contracts are the same. This contract basically pays money to Bob on the condition that he releases the secret random number. If Bob releases his pre-image, he receives money. Otherwise, Alice receives back the money. In this contract, hash image can be used as a part of an invoice. And its pre-image can be act as a receipt or proof of payment. In the Sphere, we use a slightly different contract. It's called HTLC. In the new contract, we use two hash images instead of one hash image. One of these hash images is selected by Alice and another one by Bob. If Bob wants to claim a payment, he not only has to release his secret pre-image, but also he needs Alice's pre-images. This method prevents Bob from overdrawing, as Alice will never allow to do so. By this method, both Alice and Bob can control the payment channel. Now I want to explain the procedure of making a payment in Sphere. Sphere makes a payment in 4 steps. In the first step, Alice receives an invoice through an out-of-band channel from Bob. This invoice includes the amount that she has to pay and the hash image that Bob generates. Sphere allows Alice to decide how to divide a payment. So Alice determines the number of partial payments and the amount of them. In the second step of Sphere, Alice selects several payment passes to send partial payments to Bob. For each pass, she sets an amount of partial payment and a unique hash image. Then she initiates the transfer of the partial payments altogether. Each partial payment has a unique hash image chosen by Alice and the same hash image chosen by Bob. In the third step of Sphere, when Bob receives the partial payments, he uses the out-of-band channel and informs Alice and requests her for her pre-images. Bob used these pre-images to claim the payment. So Bob reveals in response, Alice reveals a subset of pre-images to Bob. To prevent Bob from overdrawing, Alice makes sure the sum of partial payments corresponding to the pre-images that release is equal to the amount in the invoice. In the fourth step of Sphere, Bob claims the partial payments whose pre-images have been released by Alice. Bob claims these pre-images if the sum of them is at least equal to the amount in the invoice. And also, he has enough time for all these partial payments. In this step, Bob also cancels the other partial payments that he received. Implementing a Sphere is really simple. Each partial payment is handled similar to the formal single payment method with only one exception. The exception is that transfer of payments must be conditioned on the release of two pre-images instead of one. Consider the Carol and the David channel as one of the channel in the partial payments passes. According to basis of lightning technology, Bolt, Carol must create an HTLC with David. For creating an HTLC, she has to send an update at HTLC message to David. In a Sphere, Carol has to create an H2TLC instead of HTLC. So she must send and update H2TLC message. The update at H2TLC message is basically an update at HTLC message with an additional field, which carries Carol's hash image. The main object of redundant payment is to reduce the payment latency, that is the time needed to complete the payment process. For estimating the latency of Sphere, we should know that Sphere uses the two types of exchanges. The first type of exchange is exchange over the Lightning Network. We consider the average round trip time between two nodes that have a channel in the Lightning Network is about delta seconds. And the length of the longest path of partial payments is L. Another type of exchange is exchange over an out-of-band channel, which is faster than the previous type of exchange. We consider the average round trip time between Alice and Bob in this type of exchange is about gamma seconds. Now we want to calculate the latency in each step of Sphere. In the first step, Sphere needs a single round of communication over an out-of-band channel for receiving Bob's hash image. So that means this step requires gamma seconds. In the second step, Alice transfers partial payments parallelly. For estimate the latency in this step, we calculate the time needed for the partial payment in the longest path Each channel, for each channel, the channel holders has to create an HTLC, which needs 2 rounds of communication. So that means this process requires about 2 delta seconds. This process is repeated over L channels for the longest path. So that means that the second step of sphere needs 2 delta L seconds. In the next step, a sphere requires a single round of communication over the out-of-band channels. In this step, Bob informs Alice for the receiving partial payments, and in response, Alice sends the corresponding images to Bob. So this step needs gamma seconds. In the fourth step of sphere, Bob releases images to Alice for claiming the partial payments. Similar to the second step, this step requires about 2 delta L seconds. As a result, the delay for sending a payment in sphere is about 4 delta L plus 2 gamma seconds. Sphere is faster than the previous method. The previous method is called boomerang. Boomerang needs 6 delta L plus gamma seconds for making a payment. As you can see in the figure, for a payment pass of length 3 in a sphere, the maximum lifetime is 3 delta. Delta is a time set that a node can redeem a fund on the chain. This maximum lifetime is equal to the maximum lifetime set in single pass payment method. However, boomerang needs the maximum lifetime of 6 delta, which is twice what is needed in sphere. Therefore, in the worst case, funds can be locked for a shorter period of time in sphere than boomerang. Sphere allows Alice to decide on her own how to divide the payment. Also, sphere allows to divide the payment into unequal partial payments. By this method, Alice has a high flexibility to handle the payment. In the Lightning Network, an intermediate node can stall a payment for hours by accepting an incoming payment and not forwarding the payment to the next node in the path. In the single pass payment method, Alice has to wait until the payment is canceled. Then she can make a second attempt to make a payment. HTLC-based multi-pass payment methods are also vulnerable. A misbehaving node also can stall a single partial payment, and Alice has to wait until the partial payment is canceled before making a second attempt. Multi-pass payment methods with redundant passes naturally mitigate this issue because these methods support redundant passes, and as long as Bob receives enough partial payments, the payment goes through. In a sphere, intermediate node misbehavior can only delay the process, freeing up the liquidity of its own path. However, another method, delay is for all partial payments. In the sphere, Alice sends partial payments through different passes. So she has to pay different fees for partial payments. Some of this fee is higher than others. In the sphere, Bob can help Alice to reduce her fees by reporting all partial payments that he received. So a sphere allows Alice to choose the subset whose sum of fees is minimal. To summarize, we proposed a sphere, a simple multipass payment method with redundancy, and showed how a sphere can be implemented in the Lightning Network. Moreover, we compare a sphere with Boomerang, the only method in the literature that used the redundant payments. Also, we show that a sphere has several advantages over Boomerang, including lower delay and ease of implementation. Thank you for your attention.
Thank you very much, Sonbol. This was a great talk. Thanks.
Thank you.
Any questions from the audience? So feel free to use the Q&A tool in Zoom or the chat. I will start to get started. So could you comment on the privacy properties of Sphere?
The privacy is similar to the multipass payment method. There is no difference between them. But because we use the out-of-band channel, maybe sometimes you don't need a lot of privacy. For example, you go to buy a coffee, you can see the person you want to pay. So it's not really important for you. You can use a Sphere because the out-of-band is you talk to person. You don't need another method for out-of-band channel. But in the general, the privacy is similar to the multipass payment method.
Very good. I was basically wondering whether due to the increased speed, there's some drawback in privacy, right? Some kind of inherent drawback that is hard to fix. So I think a follow-up question would be, how do you select paths? I mean, do you assume a total view of the network?
We didn't explain a special method for that because some of the users have different aim. For example, some want the payment be fast, or some wants to the payment be with low fees. So we didn't explain a special method for finding the passes.
Okay, fair enough. So I think we have time for one more quick question before we have to move forward. So what type of out-of-band channels do you assume exist for those partial payments that you mentioned?
I say that, you don't need a special out-of-band channel. In the Lightning, we have an out-of-band channel because we send the pre-images and the hash of the pre-images in the simple method of sending the payment in the Lightning Network. So we can use that out-of-band channel, or I say that you go to the coffee and you want to pay, you can see the person and you can use a Q code, something like that.
Okay.
Is not a special thing for out-of-band channel.
Thank you very much for your answer and for your great talk.
Thank you.